Hello, Chuck Backus with Toolmex. Precise cutting requires choosing the proper chuck, like TMX chucks.
However, your chuck will only perform well if you properly mount the chuck backplate. A properly mounted chuck spins concentrically, contributing to low axial and radial runout and delivering precise cuts. You can even compensate for improper spindle rotation with proper backplate mounting. Your TMX chucks are designed to be fitted once and then can be remounted again and again in one simple step to deliver consistent, accurate results. TMX chucks meet DIN and American standards and are interchangeable with the backplate mounting dimensions used for other top quality chucks sold in the US. Before you get started, make sure you have collected the necessary tools and equipment to perform the installation. Step 1, choose the correct backplate. There are 5 types of backplates for different spindle noses. A is for short tapered backplates that are flat without any protruding mounting parts. D1 is for short tapered backplates as well and is easily recognized by the camlock studs on the back of the backplate. L is for long tapered backplates. Threaded is for threaded spindle noses. Type C, German DIN standard hex nut studs. To determine the correct backplate for your application, check your spindle type and chuck size. To identify the size of the lathe spindle nose, measure the camlock hole diameter or measure the camlock stud OD diameter with a caliper on your existing chuck or backplate. Refer to your chuck product manual for the spindle that corresponds to the correct backplate size. And for this demonstration, we are using a TMX 8-inch self-centering plain back scroll chuck requiring a D16 type backplate. If you are unsure which backplate to use, call TMX customer service at 800-992-4766 or visit our website at toolmex.com. Step 2. Clean the spindle nose with a clean shop rag. It is highly important to have a clean surface for accurate measurements. Step 3. Measure the radial and face runout of the spindle nose. The accuracy of your spindle directly influences the accuracy of your chuck. If your spindle has runout, you can still compensate for this by properly measuring the irregularity and applying a face cut to the back plate to balance the spindle. However, too much runout may require another chuck solution. Use your dial indicator and measure the radial and face runout of the spindle nose. The measured face and radial runout cannot be larger than is shown in the chuck manual spindle nose specifications. If the runout is greater than the specification, a TMX chuck with an adjustable body chuck must be used. In this case, our runout is 1/1000 on our radial and 1/2 on our face, and therefore within our specifications, and we're good to go. Step 4 is mounting the back plate. This is the D16, and we're going to put the cam studs into the spindle holes, tightening all 6 cams located on the flange of the spindle, making full engagement between the cams and the camlock studs. Similar to changing a flat tire on a car. After snugging the first stud, snug the one 180 degrees opposite to evenly pull the taper of the chuck into the taper of the back plate. Be sure that the back plate sits properly on the spindle nose. Step 5. Check the back plate for fit. Now check if there is any gap between the spindle face surface and the back plate surface of the spindle nose. If there is a gap, dismount the back plate rotate it 180 degrees, and then remount following the previous steps, making sure to inspect and clean the spindle nose and chuck backplate. Step 6. Measure the chuck counter bore diameter. Measure the chuck counter bore diameter with a caliper to determine how much of the backplate needs to be cut. Remember, this needs to be a press fit. Take a gauge cut on the backplate before you measure the boss diameter to determine how much to cut. At this point, it's important to measure the ID of the chuck counter bore and the OD of the backplate. And the counter bore measures 6.299. And the OD of the backplate is 6.3. Now we need to cut the difference so the chuck will fit. Select and install the proper indexable tool holder with carbide insert into the tool post. When selecting the insert, keep in mind that you will be machining cast iron. Select the feed and speed recommended by the insert manufacturer. Step 8. Face the backplate flange surface and turn down pilot diameter. Face or true the backplate flange face surface and turn down the diameter of the backplate pilot or boss to meet the chuck counterbore diameter requirements. Make sure to press fit the backplate to the chuck to ensure an accurate fit. Be sure that the length of the backplate pilot is shorter than the chuck counterbore depth. If it is longer, face it down until it is shorter. Step 9. Clean counterbore and backplate with a clean shop rag. Clean the chuck counterbore and backplate face surface, being sure that they are free from dirt, chips, and other materials. Step 10 is mounting the backplate. It's important to reference the 0 cam lock on your backplate prior to removing it so you can repeat its position. Next, we need to remove the backplate, so place it on the chuck. Check the location of the mounting bolts, matching them with the backplate mounting holes. Gently slide the chuck on the backplate boss. Screw in the mounting bolts, making a few turns of each bolt by hand until you first meet resistance, going around the back plate. Applying the 180-degree snugging principle we talked about earlier will help to evenly distribute seating of the backplate to the chuck. Tighten down each bolt gently using a good quality hex key. Repeat the operation until the chuck has full engagement with the backplate pilot. Check to see if there is any gap between the back surface of the chuck and the face of the backplate. If there is a gap, dismount the chuck. Check and clean any foreign objects. Rotate the chuck 180 degrees and remount, making sure to screw in bolts the same as before. Now that the backplate has been attached to the chuck, we need to find our mark and our 0. Line the holes up properly. Bang. Step 11, measure radial and face runout. This is the final step in our mounting process before we move on to actually checking the machine's ability to cut. With our dial indicator, we can check the face. It's important that we bring the jaws of the chuck all the way in, making space for clearance for the indicator. Use the dial indicator to measure the chuck radial and face runout. It should not be greater than 2 thousandths. And in this case, it's running perfectly true. Now that we've mounted our chuck, let's machine our first workpiece to test the chuck to see if it's operating properly. Step 1, insert workpiece. Insert a steel shaft into the chuck jaws. Set up the shaft to your desired position and length. Step 2, tighten jaws on workpiece. To achieve maximum accuracy, tighten the jaws on the workpiece with the pinion marked 0 using the self-ejecting wrench. The 0 marked pinion is designed to provide maximum gripping accuracy. Tighten the workpiece in the desired position. For heavier machining, use the other 2 pinions on your TMX chuck after the 0 pinion to tighten the workpiece with greater gripping power. Step 3, support with live center. Support the other end of the shaft with a TMX live center. Step 4, set up cutting parameters. Set up the desired cutting parameters on your machine. Before starting your machine, note the following for your safety. The maximum rated chuck RPM is stamped on the face of your TMX chuck and is also provided in the manual. Never run your chuck at a speed higher than your chuck is rated for. Read your machine manual for the maximum length of a workpiece for which your lathe can support. Step 5, machine, shaft, and check for accuracy. Now that we have our stock mounted, let's machine our first workpiece to determine accuracy of the chuck. We're going to machine one end, then we're going to remove the workpiece, place it in the opposite direction, and machine the opposite end. And when the 2 cuts come together, we'll measure it to determine accuracy. To run this test, machine the shaft from one end, cutting as close as safe to the chuck jaws. Stop the lathe, release the workpiece, and insert the machined end in the chuck jaws. Following the same insertion process as above, remembering to tighten the jaws using the pinion mark 0. Repeat the machining for the uncut end and measure the step between the first and second cut with a caliper or micrometer. If the step is the same or less than the maximum runout specified in your chuck manual, the backplate mounting is correct. For this 8-inch chuck demonstration, the runout specification is 2 thousandths. Everything looks good. Chuck dismantling and remounting. If you need to use another chuck, you can mount it on the same backplate as long as the other chuck has mounting dimensions that meet DIN and American standards. Step 1, release the backplate mounting bolts. Release the backplate mounting bolts, unscrewing them completely. Take 3 mounting bolts and insert them into the threaded ejecting holes. Make a few rotations of each bolt and repeat until the chuck is disengaged with the backplate. Remember to secure the chuck against falling down on the lathe bed. Step 2. Mount the new chuck as previously described.